Your Ford F-150 has built-in factory settings and design choices that are quietly choking off oil to its most expensive components. And you will never know anything is wrong until a turbocharger completely lets go, or your engine starts rattling itself to death. Most owners have no idea that the very features marketed to save them a few pennies at the pump are actively destroying their powertrains from the inside out. I have been working on these EcoBoost trucks for over 15 years, and I see the exact same failures roll through my bay week after week. Scored bearings, excessive shaft play, clogged oil screens, and stretched timing chains. The owners didn't do anything obviously wrong. They simply trusted the truck's factory programming and ignored a few critical habits that Ford never bothered to explain clearly in the owner's manual. Today, I am exposing 5 factory settings or features that are causing hidden damage and severe mechanical inefficiency without you ever knowing it. Setting number 3 has caused more catastrophic engine teardowns in my shop than almost anything else. And setting number 1 is so incredibly deceptive that most owners actually think it is beneficial to their truck, when in reality, it is doing the exact opposite and starving your engine for protection. Let's get into it. We start with setting number 5, your auto start-stop system. On almost every modern F-150 equipped with the 2.7 or 3.5-liter EcoBoost engine, this system is programmed to shut the engine completely off the exact moment you come to a stop with your foot on the brake. Then fire it back up the second you release the pedal. Ford put this feature there to help meet strict federal fleet fuel economy targets, not to make your high-performance engine last longer. But here's what Ford doesn't tell you. Your turbochargers spin at well over 100,000 revolutions per minute under load, and they live entirely on a microscopic, constant film of pressurized engine oil flowing through a center journal bearing. When the engine shuts down at a red light, your oil pressure drops from a healthy 30 psi to exactly 0 instantly. The turbocharger shaft is still coasting at high speed, and it is brutally hot from exhaust gases that routinely exceed 1,200 degrees Fahrenheit. But the vital oil supply is suddenly gone. Imagine you have just driven 20 minutes across town on the highway. Your turbos are completely heat-soaked. You pull off the exit ramp and hit 5 consecutive red lights on the way to your destination. That is 5 hard, immediate shutdowns and 5 metal-on-metal restarts. Each stop represents a critical moment where that spinning turbine shaft is grinding against its bearing with little to no fresh, pressurized oil reaching it. Over tens of thousands of driving cycles, this cumulative abuse adds up to severe bearing wear and the kind of excessive shaft play that ends in a whistling, smoking, failed turbocharger. The actual fuel savings from this feature are an absolute joke, ruefully 1/10 to 3/10 of a mile per gallon in real-world driving. Over an entire year, that saves you maybe $30 to $50 in gasoline. Meanwhile, a proper turbocharger replacement on these EcoBoost trucks runs anywhere from $1,500 to over $3,000 once you factor in the high labor costs and the manifold bolts that inevitably snap during removal. The fix for this costs you absolutely nothing. There is a physical button located near your shifter or on the center console, marked with an A circled by an arrow. Make it an unshakable habit to press that button every single time you start the truck. This disables the system until the next key cycle. If doing that manually bugs you, you can spend $100 to $150 on an aftermarket inline module that permanently remembers your preference and keeps the system off automatically. For the long-term survival of your turbo bearings, it is one of the smartest, most small investments you can make. Setting number 4 is one that Ford actively markets as a smart efficiency benefit, but under everyday working conditions. It creates the exact environment that destroys your internal engine components. I am talking about leaving your truck in eco mode while towing or hauling heavy loads. Eco mode is factory programmed to dull your throttle response, alter the electronic wastegate scheduling, and force the transmission to shift into higher gears as quickly as possible to keep engine RPM exceptionally low. That programming is perfectly fine if you are driving empty down a flat highway. But the moment you hook up a 7,000-pound travel trailer or throw a heavy payload in the bed and leave the truck in eco mode, you are asking for trouble. The transmission will aggressively lug the engine, keeping you in 8th, 9th, or 10th gear, up a steep grade when the truck really needs to be in 5th or 6th to maintain your road speed while lugging in too high a gear. The EcoBoost engine has to heavily compensate by demanding massive amounts of turbo boost. This means your turbochargers are forced to spin at maximum capacity, generating extreme thermal energy, while the engine itself is turning at a low RPM. Low engine RPM means your mechanical oil pump is spinning slower, producing lower overall oil pressure and less volume moving through the cooling passages. You are essentially demanding maximum work from the turbos, while supplying them with reduced cooling and lubrication capacity. The turbine housings will literally glow cherry red, cooking the engine oil inside the center cartridges and subjecting the internal bearings to immense thermal stress. Ford actually buries a small warning in the towing guide advising against using eco mode under heavy loads, but they leave the truck's default settings wide open. And thousands of owners pull heavy loads in eco mode every single day, thinking they are saving money. In reality, they are baking their oil and wearing down their powertrain. The solution here is simple behavioral discipline. Match your drive mode to the actual job. Use normal mode for your empty daily commute, but the absolute second you hook up a trailer or carry a heavy load, switch the truck into Towat Haul mode. Haul mode completely rewires the transmission shift logic to hold lower gears longer, keeps the engine in its optimal power band, increases oil pump volume, and prevents the turbos from overworking at low engine speeds. Your transmission fluid stays cooler, your cylinder head temperatures drop significantly, and the oil protecting your expensive turbo bearings has a much easier, safer life. Now that you know how to stop killing your turbos with the wrong drive modes and start-stop cycles, we need to look at the even bigger traps Ford has laid for you. Settings 3 and 2 move us deep into the mechanical core of your engine, where the factory settings stop being minor annoyances and start actively accelerating major component failures. Setting number 3 is the single most destructive software configuration on your entire truck, and it is responsible for the massive wave of timing chain stretch and cam phaser failures that plague the EcoBoost family. I am talking about the factory-intended oil change interval monitor. Flip through your digital dashboard menus, and you will see an oil life percentage indicator that will happily allow you to drive anywhere from 7,500 to a staggering 10,000 miles before it flashes a warning to change your oil. Ford's marketing and maintenance schedules back this up, presenting these long intervals as a cost-saving, low-maintenance benefit of modern engineering. But here is the cold, hard reality from inside the repair bay. That dashboard monitor is a complete mathematical fiction that does not account for the brutal operational reality of a direct injected, twin-turbocharged engine. To understand why a 10,000-mile interval is flat-out killing your engine, you have to look at how these EcoBoost power plants operate. Because they are direct injected, fuel is sprayed at extreme pressure directly into the combustion chambers, rather than over the intake valves. This process naturally creates higher levels of fuel dilution, where raw gasoline washes past the piston rings and mixes directly into your engine oil. On top of that, turbochargers expose that oil to volcanic temperatures, shearing down the oil's viscosity and breaking down its protective additive packages long before you ever hit that 10,000-mile mark. When you leave oil in the oil pan for that long, it loses its ability to resist high-temperature oxidation and begins to form microscopic carbon particles, essentially an ultrafine liquid sandpaper, the primary victim of this degraded. Fuel-diluted oil is your engine's timing chain assembly. The 3.5 and 2.7 EcoBoost engines use an incredibly long, complex steel timing chain that relies entirely on oil pressure and clean lubrication to stay taut against the cam phasers. As that liquid sandpaper loops through the engine over thousands of extended miles, it slowly grinds away at the microscopic tolerances of the chain links, pins, and bushings. This physical wear causes what mechanics call timing chain stretch. Once the chain stretches by even a fraction of an inch, the engine's valve timing goes completely out of sync, triggering a loud, horrifying metal-on-metal rattling sound upon cold startups and throwing a P016 or P017 diagnostic trouble code. By the time that light hits your dash, the damage is completely done. You are looking at a mandatory, highly invasive front engine teardown to replace the stretched chain, worn guides, and ruined cam phasers, a job that routinely costs between $2,500 and $4,000 in my shop. The dashboard monitor completely ignores this cumulative wear because its algorithm only estimates oil life based on generic engine revolutions and operating tempi, ratures. It has absolutely no physical sensor to measure fuel dilution or oil shear. The solution to this problem requires you to completely ignore the factory dashboard monitor and take control of your own maintenance schedule. If you want your EcoBoost engine to survive past the 100,000-mile mark without a major timing chain failure, you must dump the oil and filter every 3,000 to 5,000 miles maximum, especially if you idle frequently, tow heavy loads, or take short trips where the engine never fully warms up to burn off fuel vapor. Changing a high-quality, full synthetic oil at a 5,000-mile limit is the single cheapest insurance policy you can buy against a catastrophic engine rebuild. That brings us directly to setting number 2, which is an architectural defect disguised as a high-tech safety feature. I am talking about your truck's electronic oil pressure display or gauge layout. Look at your dashboard cluster while the engine is running, and you will see a beautifully designed gauge with a little oil can icon, pointing comfortably right in the middle of the normal zone. Ford configures this display to give you total peace of mind, making you believe that an advanced computer is constantly monitoring the exact, real-time fluid pressure feeding your engine's most delicate components. It is designed to make you feel safe, but from a technician's standpoint, it is one of the most deceptive pieces of programming ever installed in a vehicle. Here is the dirty secret behind that dashboard gauge. It is not a real pressure gauge at all. It is what we in the industry call an idiot light with a needle. The engine is not equipped with a variable, real-time oil pressure sending unit connected to the dash. Instead, it uses a primitive, binary on-off pressure switch. This physical switch is calibrated to close at an incredibly low threshold, usually around 5 to 7 psi. As long as your oil pump is producing at least 6 psi of pressure. The vehicle's computer receives a basic electrical signal and automatically commands the dashboard needle to sweep right up to the middle of the normal range. This means your engine could be severely starving for protection, running at a critically low 8 psi under load when it actually requires 30 or 40 psi to properly lubricate the upper cylinder heads and the turbocharger feed lines, and your dashboard gauge will still proudly sit right in the center, telling you everything is perfect. This deceptive programming completely blindsides owners. I have had countless trucks towed into my bay with completely seized turbo bearings, wiped cam journals, and destroyed rod bearings, and the owners always tell me the exact same thing. I don't understand what happened. My oil pressure gauge looked completely normal right up until the engine died. The consequence of trusting this fake setting is that by the time that dashboard needle actually drops to 0 or flashes a warning light, your engine has already been running below a safe lubrication threshold for miles, and fatal. Metal-on-metal mechanical destruction has already occurred. The solution to this factory deception is to stop relying on the physical dashboard instrument cluster to gauge the true health of your lubrication system. If you want real-world data, you need to bypass Ford's dummy programming entirely. You can do this easily by utilizing an aftermarket OBD2 scan tool or a digital monitor display that plugs directly into your truck's diagnostic port underneath the steering column. By pulling live data streams through software like 4RScan, you can read the actual inferred or calculated pressure values that the powertrain control module sees, or better yet, you can have a certified technician install a true mechanical oil pressure sending unit with an auxiliary gauge inside the cabin. Knowing your actual, real-time oil pressure numbers is the only way to catch a failing oil pump, a clogged pickup tube, or a collapsing oil filter before it destroys your entire investment. We have uncovered the damage caused by fake pressure gauges, stretched timing chains from long oil changes, incorrect drive modes, and the constant strain of start-stop cycles. Now, we have finally reached setting number 1, the single most deceptive, widespread, and mechanically devastating feature on your modern Ford F-150. It is a setting that almost every single EcoBoost owner actively interacts with and trusts implicitly, believing it is a highly engineered safety benefit, when in reality it is the ultimate silent killer of your engine's most expensive components. I am talking about Ford's factory ultra-low viscosity oil specification setting, paired with the yellow oil fill cap under your hood. If you open your owner's manual or look directly at the plastic oil cap on a modern 2.7 or 3.5-liter EcoBoost engine, you will see a factory requirement stamped right into the material: Motorcraft 5W20, or, on the newest generations, an incredibly thin 0W20 oil specification. Ford proudly markets these ultra-thin fluid choices as a monumental achievement in modern powertrain engineering, explicitly stating that these lightweight oils reduce internal mechanical friction, allow for quicker cold weather lubrication, and optimize the engine to deliver peak fuel efficiency. But here is the brutal mechanical reality that Ford's engineering department downplays. This oil weight setting was mandated exclusively to satisfy corporate emissions regulations and CAFE fuel economy standards, and it leaves your high load twin turbocharged engine completely starved for physical wear protection under real-world driving conditions. To understand why this factory fluid setting is a complete disaster for your engine's long-term survival, you have to understand the intense physics happening inside a working EcoBoost. Unlike a traditional, naturally aspirated V8 engine that relies on displacement for power, these smaller EcoBoost engines rely on massive amounts of forced induction. Under load, your turbochargers jam immense amounts of compressed air into the cylinders, creating astronomical peak firing pressures and generating extreme localized heat. The rod bearings, main bearings, and cam journals are subjected to pounding mechanical forces that are vastly superior to a standard engine. To keep those metal surfaces from physically touching and grinding each other into dust, you need a robust, thick hydrodynamic oil film, a literal cushion of fluid molecules that can withstand being squeezed under thousands of pounds of force. A 0W20 or 5W20 oil is thin right out of the bottle. But once it is subjected to the blistering 250-degree operating temperatures of an EcoBoost engine, and further thinned out by the natural fuel lution we talked about earlier, it shears down until it has the structural consistency of water. Under heavy acceleration, high thermal load, or while towing a trailer up a grade, that ultra-thin oil film completely collapses under the immense pressure. The oil is literally squeezed right out from between the bearing journals and the crankshaft. I have personally pulled oil samples from hundreds of trucks running the factory-specified 5W20 weight, and the laboratory analysis reports consistently show elevated ppm levels of copper, iron, and lead. When I tear these engines down, I find the rod bearings worn down right to the copper backing, and the turbocharger shafts severely scored. The engine was quite literally eating itself alive because the factory-specified oil was too thin to maintain a physical barrier between moving parts. Ford chose this thin oil specification to chase a fraction of a percent increase in fleet-wide fuel economy, completely passing the long-term wear costs onto you once the factory powertrain warranty expires. The consequence of blindly following this #1 setting is a slow, invisible, and cumulative degradation of your engine's internal foundations. Your truck will drive perfectly fine, sound quiet, and show normal operation for the first 60,000 to 80,000 miles. But underneath that calm exterior, the microscopic clearances are opening up, the main bearings are slowly losing their tolerances, and the turbocharger center sections are sustaining micro-scratches every single time you step hard on the accelerator. By the time the engine develops a deep internal knock or a turbocharger shaft snaps completely in half, the damage has spread through the entire oiling system. You aren't just looking at a minor repair anymore. You are looking at a complete, specialized engine replacement that will easily cost you $8,000 to $12,000 out of your own pocket. The solution to this systemic issue is to reject the emissions-focused factory oil cap specification and step up to a fluid weight that actually matches the mechanical demands of a twin turbocharged engine. For over a decade, my definitive recommendation for any 2.7 or 3.5-liter EcoBoost engine operating in real-world condition is to step up to a high-quality, full synthetic 5W30 or, if you live in a brutally hot climate and tow heavily, a specialized 0W40 or 5W40 engine oil. Moving to a thicker 5W30 weight provides a vastly superior high-temperature, high-shear film strength that can actually withstand the extreme bearing loads of an EcoBoost without collapsing. It provides the thick, robust fluid cushion your main bearings and turbo journals desperately need when the engine is working at its absolute hardest. Your fuel economy might drop by a completely unnoticeable fraction of a mile per gallon, but your engine's internal wear rates will plummet instantly, ensuring your powertrain can easily cross the 150,000 or 200,000 mile mark without a major mechanical failure. When you look at your Ford F-150 as a complete system, it becomes undeniably clear that you cannot treat it like a simple, old-school pickup truck. The factory settings, maintenance monitors, drive modes, and fluid specifications programmed into your vehicle from the assembly line were engineered to help the manufacturer meet regulatory mandates and pass initial warranty periods. They were never designed to maximize the ultimate lifespan of your vehicle. By taking control of these 5 critical areas, disabling the auto start-stop system on every single drive, avoiding the lugging traps of eco mode when hauling, discarding the fictional 10,000-mile dashboard oil life monitor, ignoring the fake binary pressure gauge, and upgrading to a robust 5W30 full synthetic oil. You are effectively overriding the factory flaws that cut these trucks down in their prime. You are stepping out of the role of a passive consumer who blindly follows the dash lights, and stepping into the role of an informed, proactive owner who understands the precise mechanical needs of their machine. This is how you outsmart the factory programming, save thousands of dollars in catastrophic repair bills, and ensure your EcoBoost truck remains a reliable, powerful asset for years to come. Go out to your driveway this week. Make these simple behavioral adjustments. Change that oil on a real schedule and protect your investment. If this real-world technical breakdown is going to save you from a catastrophic repair bill down the road, make sure to like the video, subscribe to the channel, and hit that notification bell so you never miss the hidden mechanical truths the manufacturers try to hide. Drop a comment below and let me know exactly which of these factory settings you are going to change on your truck today. I'll see you in the next one.